what new information you've been studying since the book came out about archaic humans and the relationship between modern humans and Neanderthals. Can you explain again what you're studying these days?
Well, I think what's very interesting is that what we have data from now are modern humans, the sequences of people living today. And we also have data from Neanderthals, who are archaic humans who lived in Western Eurasia for the last couple of 100,000 years. And we have now sequences from many Neanderthals. And we also have DNA from Denisovans. Denisovans are archaic humans who were discovered from the DNA from a finger bone that was found in a cave in Siberia, not anticipated to be a new group of humans, but were sequenced. So we have DNA from these different sources, plus bits of DNA from these sources mixed into modern populations. And based on this, in the last 10 years or 14 years, we collectively have been piecing together an understanding of how modern humans are related to our closest relatives who are now no longer with us in unmixed form, the Neanderthals, Denisovans, and maybe others who are no longer not yet sampled.
Mm.
And the model that we have is really a model based on accretion. So we start with the modern humans, and then we add the Neanderthals once we obtain that sequence, and we add the Denisovans. And then the model doesn't quite fit, and we add other mixture events to make the model fit. And at this point, there's a number of these mixture events that seem increasingly implausible. They feel to me a little bit like, I don't know if you know the history of models of how the Earth and the Sun relate to each other in ancient Greek times, but there's these epicycles that were attached by the Greek Hellenistic astronomer Ptolemy to make it still possible to describe the movements of the planets and the stars, given that a model where the sun revolved around the Earth. And we've added all of these epicycles to make things fit. And one wonders whether there's some pretty fundamental differences that might explain the patterns that are observed. So just to give you an example of this, the standard model is basically this, that modern humans separated from a group that is ancestral to Denisovans and Neanderthals, these two groups for which we have sequences, somewhere between maybe 500 to 750,000 years ago. That's what the genetic papers beginning in about 2012 and 2014 said, and that's still used as the explanation for the vast majority of the genealogies, the DNA lineages connecting them. So maybe except for 5% of the DNA, that's what we think is going on. Modern humans are one group, and then there's a sister of modern humans, the Denisovan Neanderthal group, and they separated 500 to 750,000 years ago. But what's become very, very clear in a really important series of papers since that time is that, in fact, there are exceptions to this. And one exception to this is the mitochondrial sequence, what you get from your mother and she gets from her mother and so on, going back in time. And there, the shared ancestor between Neanderthals and modern humans is only maybe 300,000 or 400,000 years ago, which is after the split that's very well estimated from the whole genome. And what we've also learned is that's also true for the Y chromosome. So that's inherited from your father and his father and so on. And that true, it too is only maybe 300,000 or 400,000 years separated between Neanderthals and modern humans. And like the mitochondrial DNA, the Denisovans are much more distant, maybe 800,000 years, 700,000 years, a million years. So the story told by these two parts of the genome is one that's really, really different from the rest of the genome and incompatible with the main story, too recent sharing. And we know in these papers that maybe a few percent, 5%, 3%, 8% of the DNA of Neanderthals comes from a gene flow event, a migration event into the ancestors of Neanderthals from the modern human lineage a few 100,000 years ago. And it's tempting to think that both the Neanderthal mitochondrial DNA and Y chromosome come from that event. But the probability of that happening by chance is only 5% squared, which is a very, very small number. And people have evoked epicycles, for example, natural selection for the mitochondrial DNA coming from modern humans, or natural selection coming from the Y chromosome coming from modern humans, somehow being more advantageous and pushed up in frequency. But that would have to really happen on both these parts of the genome to produce this pattern. And it just seems surprising. So what's been put together is a complicated model and epicycles, ideas like natural selection, to kind of make it work. It's not impossible. It may be the case, but one wonders whether profoundly different models might actually explain the data. And so that's something that we and others have been thinking about. Can there be other models? An example of another model that might be able to explain the data that we've been playing with is one where there's much more DNA in Neanderthals from modern humans than the 3 or 5% that's been estimated. And we
Hmm.
can get such models to fit, but here it's 30% or 50% or 70%. So, in that view, Neanderthals and Denisovans are not sisters. In fact, modern humans and Neanderthals are just as qualified to be sisters as Neanderthals and Denisovans. And in that case, maybe it's not clear what's modern and what's archaic. Are modern humans archaic? Are modern humans modern? Are Neanderthals archaic? Neanderthals are modern. What's also become clear in the last few years in a separate thread of research, not based on ancient DNA, but based on using more and more powerful and sophisticated ways of pattern finding in modern data, is that modern humans are also highly substructured. We can see that even without having ancient DNA
Hmm.
yet. Of course, once one has ancient DNA, it's so much clearer. But it's very clear that you can't explain, for example, modern African DNA without invoking very extreme substructure as deep as the mixtures that produced Neanderthal, contributed and mixed between Neanderthals and modern humans. And so that mixture, which of those groups were archaic, which of them were modern, were they both archaic, was one of them modern, was one of those more closely related to Neanderthals and the possibly higher proportion of ancestry. It's not obviously wrong that the model's very, very different from the standard one that we currently have.
Interesting. So, I mean, from your book, I remember that there are lineages of modern humans that are over 200,000 years separated from other groups, like the San hunter gatherers from everybody in Eurasia today, or at least everybody descended from Eurasia. So then you're saying that 100,000 years before that is when we have a sister lineage with Neanderthals. Actually, I'm not sure what the new findings we're finding about how closely related Neanderthals are to us and how much mitochondrial and Y chromosome DNA they share. What model do you think is the most plausible to explain why there's so much shared ancestry?
I'm very agnostic. I really, really don't know.
But the models you were just talking about, sounded like you thought they were low probability. Is there one you think is like more
I
plausible?
think the models that are considered to be standard dogma are now low probability.
Yeah,
So there's a standard dogma that's developed over an accretion of papers where the data, the history gets patched. So someone sequences a genome, someone performs an analysis, someone proves something that wasn't known before. And so we claim a mixture event. We didn't know about it before, an event that we didn't know before. And that gets patched onto the current model, which is now a
mm,
series of patches.
interesting.
And nobody has really rethought the whole thing very hard. And the whole thing is not obviously very, very different. So you can actually reassemble the whole model in a new way without doing it from the ground up or from the simple model up, but in fact, thinking about it again and seeing if it can be all related in new ways. And in fact, it might be actually quite different in the way that I just described.
Where did the gene flow between the most recent gene flow between Neanderthals and humans? I guess not the most recent, because the most recent was 60,000 or whatever years ago. But like the one you're referring to here, where physically did that happen?
Uh, Even that's not clear, but probably such a thing would have occurred somewhere in the Near East or in Western Eurasia somehow. And it's not even clear where the modern human lineage at that time was residing. So probably the modern human lineage was. Leading to the great majority of the ancestors of people today was
Yeah,
in sub-Saharan Africa for the last 500,000 years at least, and
yeah.
maybe much more. Certainly, our main lineage was in Africa probably 3 million, 5 million, 7 million years ago. But in a period between about 2 million to 500,000 years ago, I think it's not at all clear where the main ancestors leading to modern humans were. There were humans throughout many parts of Eurasia and throughout many parts of Africa with a parallel increase in brain size and not obviously closer ancestrality to modern humans in one place than in the other. It's not clear where the main lineages were. Maybe they were in both places and mixed to form the lineages that gave rise to people today.